Hello, this is lesson 4.3, and today we are going to deal with simplifying fractions. To start this lesson, what I want to do is just kind of explain a little bit about equivalent fractions and then kind of lead into simplifying fractions. So this will not be on your notes sheet that you have to do anything with, and I just kind of want to show you this. So just kind of watch here. What we've got here is I made a rectangular array, and in this rectangular array, what I have is I filled in, as you can see, 6 boxes or 6 rectangles in orange, and there's a total of 8 boxes. I'll just kind of count this filled in: 1, 2, 3, 4, 5, 6, and then there's a 7th and 8th one that are not filled in. So you could say that there is 6/8 of the boxes filled in. Now what I did is I took that same orange region and I broke it up in a different way with different rectangles. And now there is 1, 2, 3, 4, 5, 6, 7, 8, 9 that are filled in, and 10, 11, 12, 3 that are not filled in. But as you can see, there's 9 out of the 12 that are filled in. Now, if you're looking at these two fractions, you can see that, as the picture shows, that they have the same amount filled, colored. If you're taking the big rectangle as a whole, they have the same amount filled in. And so one thing we'll be dealing with in this lesson is how these two fractions, 6/8 and 9/12, are actually equal to each other. But not only are they equal to each other, they're actually equal to this array here. And this array has just 3 big boxes filled in, and they're very easy to count. 1, 2, 3, and then a 4th one that is not filled in. So both of these fractions are equal to the fraction 3/4, or 3/4. And so one of the main concepts we'll be dealing with is understanding how fractions are equivalent to each other. I normally put this down in the corner so I can keep track of the time. I realize that. So I'm going to move it down here so I can still kind of see it at the time. All right. So moving on with your notes. So simplifying fractions. Simplifying fractions. So our goal for today is to be able to simplify fractions. And we're really going to build off of the idea of finding the GCD. Sorry, not the GCD, the GCF, the greatest common factor, and using that to cancel out. Really a lot of the factoring idea. So what we want to do is write this in simplest form. And so looking at this fraction of 22/16, it looks like maybe you cannot simplify it. But what you need to do is you need to factor completely both the numerator and the denominator. So off to the right here, just off to the side kind of, I'm going to do 22, and I'm going to make my factor tree. 22 factors to being 2 times 11. So over here by the fraction then, I'm going to rewrite the numerator as the product of 2 and 11. Now I'm going to take 116 and I'm going to factor this using the factor tree. And I'll think of the biggest number, maybe, well, just any number that is a factor of 116, so I can use that. Looking at it, maybe we'll just start with 2. 2 and 58. 58 times 2 is 116. But now 58, I can factor further also. And looking at it, I'm going to do 2, and then 2 will be 29. And I can check this by using my calculator here. I can check it, if you remember, we talked about this. I'm not quite sure why this isn't working here. Hold on. Okay, sorry, I guess that did not work. But you could check this and take 2 times 2 times 29. And I wish my calculator worked there so I could show you. And you get 116. And so we'll break up and rewrite the denominator as 2 times 2 times 29. And then we'll come through and any of the common factors we'll get rid of. And so their GCF is 2 because they both have a factor of 2. Now there's another 2 for 116, but we only need to use one of them. So the GCF equals 2. And so that is what we will cancel out here. And so by canceling that out, what we're going to get is, well, they cancel, and this is kind of an important idea to understand. They don't just cancel out to be nothing. They cancel out to be 1 over 1. And so then you take 1 times 11, which is 11, and 1 times 2 times 29, which is 58. And this, I would like to box this answer because that's my final simplifying answer. That is your simplified answer for this problem. Another way to kind of look at it, since we found the GCF to be 2, is we could just divide 22 and divide that by 2 because that was the GCF, and that gets us an 11. Or we could take 116 and then also take 116 and divide by 2, and that gets us 58. Another way kind of to look at this fraction as how it's 22 over 116, and how that equals 11 over 58. So now, scrolling down here, our next problem, we have 12 and 30. So again, we want to factor the 12. Using the factor tree, that's 4 times 3, and then 4 is 2 times 2. So 12 is 2 times 2 times 3. That's the prime factorization of 12. And then we do the same thing with 30. 30 is 3 times 10, and again, you could do a couple different things. If you knew that 30 was 6 times 5, you could go that way. We'll get the same factors because every number has a unique prime factorization. 10 the factors of 10 would be 2 and 5. And so all the factors, the prime factorization of 30 is 2 times 3 times 5. And so again, we write this over, and it's 2 times 2 times 3 in the numerator, and the denominator is 2 times 3 times 5. And what we are going to do here now is cancel out. The 2's cancel out, and the 3's cancel out. We are left with, and remember, they just cancel out to be a 1 and a 1 and a 1 and a 1. But 1 times 2 times 1 is 2, and 1 times 1 times 5 is 5. Because whenever you multiply by 1, it's the identity of multiplication, so therefore you get that same number. So you get 2/5. Again, just to kind of reiterate another way to look at it, if you took and found what the GCF was, the greatest common factor of 12 and 30, just to kind of relate this to what we've been talking about, is 2 and 3 are the factors that they have in common. And so you multiply those common factors, those from the prime factorization, take 2 times 3, and you get 6. And so another way to look at it is 12 divided by 6 equals 2, and 30 divided by 6 equals 5. And therefore, 12 over 30 becomes 2 over 5. Okay, so then in the next problem, 25 over 40. So again, we'll do the same kind of thing. 25, its prime factorization is just 5 times 5 using the factor tree. And then 40, its prime factorization, first we say 40 is maybe 4 times 10, and 4 is 2 times 2, and 10 is 2 times 5. And so our prime factorization is 2 times 2 times 2 times 5. Well, we do that over here now. We rewrite it 5 times 5. And for 40, you get 2 times 2 times 2 times 5. And so there, you come over and you cancel out one of the 5's just. That's all it cancels out. So what we get then in the numerator is 5 times 1. Remember, that's a 1, which is 5. And in the denominator, we get 2 times 2, which is 4, times 2, which is 8, times the 1 for the 5 that canceled out there. So 2 times 2 times 2 times 1, which is 8. And so this simplifies to 5/8. If you're looking at it, the GCF again is 5. So basically we divided by 5. And you can see that when you look here, you can see that we divided by 5 because that's what we canceled out right there. Okay? This 5 here and this 5 here. Oh, that's not what I really wanted to have happen, but that 5 there and that 5 there. Okay. So that is example 1. Now scrolling on to the next example. Let me see here. We are now trying to figure out if these fractions are equivalent. So what we want to do with all of the numbers here is find their prime factorization and see if we get the same value. Not what I wanted here. Just a regular pen. So, well, one thing you might notice already, or might know, is that 5 is prime and 7 is prime. So there is no way to reduce 5 over 7 because they're both prime numbers. So therefore, we just have to look at the 40 and see if we can kind of simplify that, and the 56. So 40 is 4 times 10, and 4 is 2 times 2, and the 10 is 2 times 5. We had just done this same number, so 2 times 2 times 2 times 5. And then 56 is 7 times 8, and 8 is 4 times 2, and 4 is 2 times 2. So our prime factorization of 56 is 2 times 2 times 2 times 7. And so what we can see here, and maybe we don't even have to write it as a fraction, we see that the 2's cancel here. Well, actually, let's write it as a fraction. I'm sorry about that. So I'm going to hit undo, undo. So we're going to write this as a fraction then, and we're going to put 2 times 2 times 2 times 2. Oops, too many 2's. Times 5 all over 2 times 2 times 2 times 7. That's multiplication. And this is what 40 over 56 equals. And so now we look and the 2's cancel, 3 2's in each one, and what we're left with is just 5 over 7, which is the fraction we wanted to see if they were equal. So yes, the answer would be yes. The fractions are equivalent. Equivalent means they are equal to each other. I don't know if we've really covered that term equivalent, but they are equivalent. They're equal to each other. All right, next problem. Write two fractions that are equivalent to 58. So here's a little technique. You can pick any number to multiply the numerator and the denominator by to find equivalent fractions. So let's think about it this way. If we have a 5 over 8, if we multiply the numerator, say, by 2, and multiply the denominator by 2, what we get is 10 over 16. Now, is that equivalent to 5 over 8? Well, if you look at it, 10 over 16 was equal to 5 times 2 over 8 times 2. And those prime numbers, and it doesn't actually have to even be prime numbers, but those numbers cancel out and you get 5/8. So one number that is equivalent to 5 over 8 is 10 over 16. Here's how this kind of works. Well, I'll tell you, although we haven't talked about multiplying fractions yet, but really what you're doing is you're multiplying the number 5/8 times 2 over 2. And 2 over 2, as most of you are kind of aware of from what I've seen in class, is equivalent to 1. And one thing you should know is when you multiply by 1, you get 5/8. It just gives a different form of the same number. And so 10 over 16 would be one answer. And so just to find another fraction that is equivalent to 5/8, pick any number. Pick your favorite number. My favorite number is 5. So we're going to multiply both top and bottom by 5. And I'll get 25 over 40. And so that would be another number, another fraction that is equivalent to 5/8. So 25 over 40. So I will box those, and those are two fractions that are equivalent to 5 over 8. And so for your homework, you'll get to do a couple that you fractions that are equivalent to a certain other fraction, and so you can kind of pick which ones you would like to do. All right, now we're moving on to some variable expressions that we're going to simplify. All right, simplify the following variable expressions. So here in letter A, we've got 18 times, or 18 CD and all over 27D. What you should realize is, well, let's talk about something else with this that I haven't talked about yet. We've been doing the prime factorization, but truthfully, if you can find any factor that they have in common, you can reduce by that. But you really want to find the greatest common factor. And I guess I was hinting towards that when we were doing, coming back here a couple slides here, when we were doing, and I told you, what's the GCF? And then we ended up dividing by that. So I'm pointing at stuff and I really can't, so I can point with this. So when we were doing the GCF here, and then I said, oh, look, we can divide by 2. And then I said, the GCF is 6 here. See the 6? And then I said, oh, look, we could divide by 6. All right? And then I said, look, the GCF here, oh, I never really did this one. The GCF here was 5, and we could just divide by the 5. So really, if you can find the GCF of two numbers, you can divide by that, and it's a lot quicker. So if we're looking at it, we don't actually have to, there was another way we could find GCFs other than doing prime factorization, and that's just listing all the factors of a number. So let's just look at it a little bit. And this is kind of stuff you could do in your head and don't really have to show work for. But these are all the factors of 18. 1 and 18, 2 and 9, 3 and 6. Now it's not real easy when they're not in order. So what I'm going to do is I'm going to rewrite them in order. So we've got 1, 2, 3, 6, 9, 18. Okay? And then I'm going to look at the GCF of 27. Or sorry, not the 27, but all the factors of 27. We got 1 and 27. We've got 3 and 9. And let me just think for a second. That would be it. And so let me write those in order. 1, 27. Oops, that's not in order. 1, 3, 9, and 27. And so now looking for the GCF, what's the biggest common factor? 9. And so what you could do is you could write this as 18 is 2 times 9. And then we just have times C times D. And then the denominator, 27, is 3 times 9 times D. And so then you can just cancel out that GCF, which is 9. And then you can cancel out the D because they have a D in common. And therefore, when you simplify 18CD over 27D, you get 2C, 2 times C, over 3. And so sometimes if you can figure out the greatest common factor in your head, that works. So looking here, this one isn't actually hard to factor out. 4 is 2 times 2. Those are both prime numbers. And then we have times x times y. And then 6 is 2 times 3. Then we have times x. So looking at it, we can cancel out a 2 in both the numerator and denominator and cancel out an x. And so to simplify this fraction in b here, we have 2y over 3. Okay, so scrolling down, our next example. This one's going to be a little more difficult because there's a couple things involved, including a negative. And so first off, I like to understand a negative as -1. We'll just kind of understand as a -1. And we're going to do this in a multiple steps if we can. What times what is 64? Now there's quite a few answers you could give me, and I wish I was here to solicit some answers from you. But I'm going to pick one. Let's try 4. Let's say 4. Oh, well, that actually works really nice. And 16. 4 times 16. Just off to the side because my calculator's not working. Let me show you that it is 64. 4 times 6 is 24. Carry the 2. 4 times the 1, which is actually 10, is 40, plus the 2, which stands for 20, is 60. So we have 64. So what we've got then is 64. So it does work out. And then we have z squared, so we have z times z. And then in the denominator, we don't even have to factor the 16 because it's going to cancel with the 16 we already have there. So we have 16 times x times y times z. And so therefore, going through, the 16s reduce out, and one of the z's reduce out. So what are we left with? Well, in the numerator, we have a negative 1 times 4, which is negative 4. And in the denominator, we still have, oh, forgot the z. Sorry about that. We have a z also in the numerator. In the denominator, we have an x times an x, which is an x squared, times a y. And so this fraction, negative 64z squared over 16x squared yz, would simplify to be negative 4z over x squared y. All right. 32. 32 is 4 times 8. And then we have times a. And then the denominator, we have 8 times a times, that's not an a, times a times b. What simplifies out? The 8s and then the a's. And so what we're left with is 4 over b. I was trying to give you another example where we could do this in multiple steps, but I realized when I picked numbers, they were working out real well. So we'll just keep it like that. Yeah, I guess that's actually what I was going to do here. Maybe, let's look at this another problem. You don't have to write this down, I guess. It's just kind of a side note. Let's say you didn't know that 8 times 4 is 32. And so you're thinking, oh, well, I know 2 times 16 is 32. And then I still have times a. And then you have, well, 8 is 2 times 4. And then I have times a times b. Well, you'll be tempted to do this and cancel out the 2's, cancel out the a's, and then say, my answer is 16 over 4b. But this is not the most simplified answer, because 16 is also 4 times 4. And then you have in the denominator 4 times b. So now the 4's cancel. So you need to keep canceling until you have all the common factors canceled out. The common factors of the numerator and the denominator. And so be careful about that. If you pick, it sometimes takes practice at getting used to that. So I know 16 over 4b seems like a great answer, but hopefully you understand that you could still simplify that further. And we're not going to do huge numbers, so you'll probably notice it, but again, it takes some practice, and we'll work on that more as we go on through this. All right, and then finally, our last example here. For example 5, evaluate the following variable expression when x equals 3. So we're going to do the same thing, except one thing you know what we're going to do. We're going to plug in 3 for x, but it's going to be a lot easier to plug in 3 for x after we simplify it. So just kind of off to the side, I want to show you the harder way to do this. You plug in 3 for x first. And I mean, it's possible to do this, and it's not horrible to do it this way, but it's going to be a lot easier to simplify fractions. That's why we're practicing. Because here now I have to think of what's 35 times 3 times 3 times 3 times 3. And then I have the denominator 5 times 3 times 3. And so then I have to think, well, I guess in this step you could actually simplify. But if you weren't going to simplify anything at first, you would think, what's 35 times 3? 105. Times 3, 315. Times 3, 945. Times 3, wow, 945 times 3. I can't do this one in my head so fast. So what we have is 2,835 over 5 times 3, which is 15, times 3, which is 45. And then you would still have to reduce that. Of course, a couple things. As you saw how I wrote it here, you could have reduced from the beginning. But even here, if you think 35 times 3, which is 105, no, 105. 105 times 3 is 315. If you think 315 over 5 is your answer, it's not, because the 5 reduces. So what's going to be a lot easier before dealing with all that is before plugging in 3 for x, if you simplify it. Now 35, prime factorization is 5 times 7. So we have 5 times 7, and then x to the fourth is x times x times x times x. And then 5 times x squared is 5 times x times x. Now watch this, because there's something good that happens here. The 5's cancel, the x's cancel, and another x cancels. Now, the question kind of comes up, what's in the denominator? We've canceled on everything. Is it 0? No, remember, when we cancel, those all become little ones. So what we have in the denominator is 1 times 1 times 1, which is 1. And in the numerator, we have 1 times 7 times 1 times 1 times x times x. So we have 7x squared. Now anything, let me just kind of offset this, anything over 1 is really 7x squared divided by 1. And hopefully you understand that everything divided by 1 is that same number. So we have just reduced this number here. Let me use this special pen that I don't use in class very often. We have just taken this number here, and we've reduced that. We've reduced that down to being 7x squared. And so now what we can do is take, and we can simplify that by putting the 3 in for the x. Now, order of operations, we do the exponents first. 3 squared is 9, and then you take 7 times 9, and you get 63. And you might be wondering, how is that the same as 35 over 5? Well, why is my calculator not working? Let's see if we can get it to work now. It just isn't working. I'm pushing the buttons and nothing's happening. Maybe if I turn this on and then turn it off. Let's see. So if I take 3, oh, no, see, that worked. 315 divided by 5, look at what I get. I get 63. Where am I at? 63. So that is the same right there. All right, so that concludes what I wanted to show you. Looking at the clock down in the corner here, this lesson took 27 minutes. So, you know, if we're on a normal day, you have 45 minutes. So 45 minus 25, 27, oh wow. You've got about 18 minutes left in class, a little less than. With this time, I want you to work on the homework. Work nicely and work quietly, and then go through that, and I will collect it, and we'll go through it, you know, tomorrow. But I'll collect it tomorrow, so it needs to be done for tomorrow. So enjoy the rest of your day.